applications that discussed in the last lecture. And after that, discuss the concept of unit number 5 that will uh, start the first unit of numerical analysis, the roots of equations and interpolations and curve fitting. And that was discussed in the last lecture. Okay, how many topics will covered in the unit number 5. First concept that will discuss the roots of equations. There are three methods: bisections, regular falsi, and Newton-Raphson's. And then after interpolations, there is a four various method. And then at last, we'll discuss the curve fitting. So what is meaning of roots of equations that I was discussed in the last lecture? We have any equations and now we have to solve it. Means for which value of x the functions become 0. Functions means the equations we have. For example, x square minus 4 is equal to 0. That is called fx. So for which value of the x functions become 0. So it is called roots of the equation. Okay, this is one types of equations we have. So this is the meaning of roots of equations, that is also known as the zeros of the equation, and it is also called the solution of the equations. Okay. So here we can find the roots of equations as x equal to plus or minus 2. Okay. This is the solutions of these equations. When we replace x equal to 2 here, we get answer is 0. And when we replace x equal to minus 2 in these equations, we'll get answer is equal to the 0. Okay. So it is meaning of roots of equations. So now it is a simple equations. Okay, x square minus 4 equal to 0. So in place of we have x square plus sine x equal to 0. Okay, otherwise e raised to x plus sine x equal to 0. So here we cannot solve it directly. It means we cannot predict such a possible answer of these equations. Okay, which is called the solution of this equation. Okay, so for this type of equations which involve such exponential term, trigonometry, logarithm term, we can apply the numerical method to solve it. Okay, to find the solutions of this type of equations. So this is the meaning of this. Here it is, the values calculate with the equations are called the roots, and they represent the values x that makes fx equal to 0. And this is one formula is given here, quadratic equations. If it is a simple quadratic equation, then we can use this formula to find the root. Okay, this is a formula to derive the answer of the solutions. Minus b plus or minus root of delta divided by 2a, where delta can be valued by b square minus 4ac. Okay, that is a simple formula, and that we all we are know that. Okay, how we can solve if we have any quadratic equation. But in place of quadratic equations, we have this type of formula. Okay, this type of equations: x square plus sine x e raised to x plus sine x. There are lots of equations we can create which involves a trigonometry, exponential, power term. So how we can solve it? Okay, so here we can apply such numerical method to solve this type of equations. Okay, so roots or solutions of the equations fx equal to 0 are the values of x for which the equations hold the true. Okay, means for x square minus 4 equal to 0, so for which value of x functions become a true, means functions become a 0. So here x equal to 2. Okay, this is the solutions of this equation, that is called roots of this equation. Okay, same for minus 2. And numericals method to find the roots of equations can often be easily programmed. Okay, we can easily apply such a various method of numericals analysis to solve this type of equations. Okay, so how many types of equations we have? There are two types of equations. One is algebraic equations and second is a transcendental equation. Okay, so what is meaning of algebraic equations? Equations of the form with the degree n are called the algebraic equations. For example, fx can be write as a0x raised to n plus a1x raised to n minus 1 plus up to the constant a, and that is equal to 0. And this one counter example is mentioned here. X square minus 2x plus 1 equal to 0, x square minus 4x equal to 0. Okay, you can create another one, x cube plus 2x plus 1 equal to 0. Okay, this all are known as algebraic equations which in the form of degree n. Okay, there is one power of the degree. Means there is one term with contain the maximum power. Okay, x square minus 2x plus 1, x square minus 4x equal to 0, x cube plus 2x plus 1. This is called algebraic equations. And the non-algebraic equations means the equations involve such trigonometry term, exponential term, where we cannot predict the degree. Okay, we cannot predict the what is the maximum power of these equations. So this type of equations are called the transcendental equations. Okay, and you have to solve this type of equations by using numerical method. How we can apply numerical method to solve, to find the solutions of this type of equation. Okay, so this is a two type algebraic form, and here we can apply, if it is a quadratic, we can directly apply the minus b plus or minus square root of delta divided by 2a formula to get the answer of the equations. Okay, means solution of the equation. But for this type of equations, we cannot apply here quadratic equations formula because it is not a quadratic equation. Okay, so here we can use the numericals method to solve it. Okay, so this is our aim in this first concept of the unit number 5, the roots of equations, and we'll discuss three various methods to find the roots of equations. Okay, in real life you can use any one, but in our syllabus there are three various methods to define the roots of equations. Okay, so next is their intermediate value theorem. What is meaning of that? We have one continuous functions. What is meaning of continuous functions? If we define, we draw it in R2 space. Okay, we get one continuous graph. This is a continuous function. Okay, there is one arbitrary fx here, and that is a graph of the fx. Okay, let us draw inside. That is one graph of the functions. Clear? So fx is a continuous function, and assume the two values. Okay, we have to predict, we have to find out the two value as a and b, such that f of a, okay, fx is given. Okay, now predict the two value a and b such that f of a is a negative and f of b is a positive. Otherwise, f of a is a positive and f of b is a negative. Okay, what is the first step to define the intermediate value theorem? Fx is a continuous function that is given, and now assume the two values. Okay, as a and b, you can consider a b from the real line. Okay, any value you can consider from the real line, and find out the f of a and the f of b, and check the answer of f of a and f of b. That should be the negative and f of b should be the positive. Otherwise, you can consider f of a is a positive and f of b is a negative. So what is meaning of what is the product? Product will be f of a into f of b. That will be the negative. Okay, why it is negative? Because here one value is a negative and second is a positive. So positive into negative will again get negative answer. Okay, for example, minus 1 into 5. What is answer? It will be the minus 5. Again, you will get a negative answer. Okay, so if fx is a continuous functions, assume the values of opposite sign at the end point of an interval AB. Okay, that interval will predict. Okay, will find as a any two real value. Okay, and such that f of a into f of b should be the negative. Okay, f of a and f of b should be the negative. And then the interval AB, okay, contain at least one root. Okay, contain at least one root of the equations fx equal to 0. Okay, and what does it mean? There exists such c belongs to AB. Okay, c will exist in the interval AB such that f of c will be 0. And what is meaning of c? The c is known as a roots of these equations. Why it is roots? Because when we replace c in place of x, will become a 0. Okay, will be the 0. So this is of a and f of b should be the positive and negative, and when we identify its product, that will be the negative. And what does it mean? Okay, the interval AB contain at least one root, okay, of the equations fx equal to 0. And what does it mean? Okay, there exists such c belongs to AB, c belongs to the interval AB, such that f of c is equal to 0. Okay, so by using this method, we can predict our root. Okay, what is roots of the equations will contain in which interval? Okay, we can predict this statement. How we can predict this statement? Okay, we have to find out the interval. Okay, आपको एक interval find करना है a and b such that f of a is a negative and f of b is a positive. Either you can, otherwise you can use also this condition. Okay, f of a positive and f of b is a negative. Okay, you can also use that. So by using intermediate value theorem, we can get ideas okay, our root will exist in the interval a and b. Okay, that belongs to the a and b. Okay, so here you can check in this graph, that is a function's fx. Okay, this is a positive y. Okay, that is a negative y, that is x-axis, and it is, let us say, a b, and let us say this is a. Okay, so at a, f of a is a negative here. Okay, for any arbitrary graph. Okay, and at b, f of b is a positive. Okay, this is a positive y, so here I get a positive value of the functions. Okay, at value of b, a and b is arbitrary value. Okay, you can use any one value for that. So what is meaning of that? Okay, by using intermediate value theorem, we can get ideas. Our roots will lies in between a and b. Okay, interval a and b, and this is our root. Okay, at this point. Okay, this point is our roots of the functions. Okay, because at that point, functions become zero. Means fx becomes zero. This is a y equal to zero line. Okay, x-axis is called the y equal to zero line. Okay, so at this point, functions will become a zero. Okay, so we have to identify this point to say this is the solutions of the equation. Clear? So this is called intermediate value theorem. You just find out one interval where f of a is a negative and f of b is a positive. Okay, and by using this, you can get ideas. Okay, one root of the functions will lies in between the interval a and b. So is there any doubt to anyone in this theorem? Have you any questions? So you can ask me. So after that, we'll start our first method of the uh, numerical analysis. So have you any doubt to anyone? Okay, good. Remaining student? Okay, nice. So let's start the first method to solve the fx. Okay, means to find the solution of the any equations fx equal to 0. Clear? So first step, for a given functions fx, okay, find the interval ab. You have to predict a two value, okay, from the real line. It may be 0 1, it may be 1 2, it may be 5 1, it may be 6 3, minus 1 2. Any value you can predict that, such that f of a is a negative and f of b is a positive. Okay, this is your first step. Fx is given in the questions, and first step, you have to find out one length, okay, one boundary, okay, where f of a, for this first point f of a, when we replace a to the functions, the output should be the negative. Okay, and when we replace a b to these functions, output should be the positive. Clear? So this is our first step, and according to the intermediate value theorem, IVT means intermediate value theorem, the interval contains, okay, at least one root between the a and b. Okay, this statement states that if uh, AB, where f of a is a negative and f of b is a positive, then by using the IVT, we can say that at least one root will contain in the length in the boundary a and b. Okay, means we can predict that there is exist one root will be in between a and b. Okay, now in next step, find the first approximations. Okay, remember one thing. Uh, by using all this method, okay, means in numerical analysis, we can predict just approximate answer. We cannot find out it perfect answer of any equations. Okay, in interpolations method, in roots of equations method, in curve fitting sections, in the numerical integrations, numerical ODE, we can just predict approximate solutions of the given questions. We cannot find the perfect answer. Okay, perfect answer means at the x, okay, fx become a 0. That is called perfect solutions. For example, x square minus 4 equal to 0. So f of 2 is called the perfect solution. Okay, because at x equal to 2, functions become a 0. But if I replace f of 1.5, at 1.5 it is not will be the 0, that it is nearer to 0, but it not will be the 0. So 1.5 is called the approximate solutions of the function. Okay, then after you can also change in place of 1.5926. Okay, so it is not equal to 2, but it is nearer to 2 there. Okay, so we say that this answer is approximate solutions of the function. So in this all method, we will derive approximate solutions. Okay, we cannot find the perfect answer, we cannot predict the perfect answer, we just check approximate answer. Okay, for this value, this is the approximate solutions of the given functions. And when we replace x, the solutions to the functions, output will become nearer to the zero. Okay, will exist nearer to the zero. So how we can check the first approximation? Okay, that is called x1. So what is the formula of bisection method? You have to bisect it, means you have to take the average of this interval. Okay, a plus b by 2. AB that you have to evaluate, where f of a is a negative, f of b is a positive. Then in first iterations, how we can derive the first iterations? We consider a plus b by 2. Okay, it is take the average. This is a formula of a bisections method. Okay, a plus b by 2. And now find the x1s. And if f of x1 is 0, okay, in next step you have to replace this x1 to the functions, okay, and check the output of the function. And if it is 0, okay, it will be the 0 there. Then what is meaning of that? X1 is called the roots of the equations. And that is meaning of the roots of equations. When we replace any value to the functions, it become a 0. Then it is called roots of the equations. So if f of x1 become a 0, then we can say that x1 is called the roots of the equation. Okay. And now in another case, if it is non-zero, okay, means there will be the two possibility that either it is positive, otherwise it is negative. Okay. If it is 0, then it is our process will stop that. Okay, at that point, and we'll say x1 is the answer. But if it is a non-zero, then we have to proceed in the next step. And in the case 1, okay, if f of x1 get a negative answer, okay, f of x1 is the negative. Okay, there is a two possibility. If it is non-zero, either it is positive, otherwise it is negative. So in the case 1, if it is a negative, okay, then we'll change our interval, okay, as a, okay, then roots lies in between x1 and the b. Okay, why it is x1 and b? Because here a is the point where f of a is a negative, okay, and b is the point where f of b is a positive. Clear? And here the formula of xn, that will be the a plus b by 2. Okay, a plus b by 2. And last column we'll check the f of xn. Okay, so in the first iterations we are using the a and b, and we'll find the x1, that will be the a plus b by 2. Okay, and then after we'll check the f of x1. If it is 0, then x1 is the solution. Okay, this is our required answer. But if it is a non-zero, then there will be the two possibility, either it is positive, otherwise it is negative. Okay, that's all. So if it is a negative, okay, suppose called negative value derive हो रही है -5, -1, -2 in the form of negative answer. So what we'll do in the second iterations, okay, we will replace this x1, okay, to the negative point. Which our negative point? A is the negative point. Why it is negative point? Because at the a functions become negative. Okay, so we'll replace this a by the x1. Correct, we'll replace this a by x1, and b will stay as it is there. Okay, b will consider as it is value, and then after in the second iterations we'll use the x1 and b. So again we'll take the average value in the second iterations, x1 plus b by 2. Okay, and you will get x2. Clear? And then after you have to check the f of x2 again, and if it is negative, okay, then again we have to replace this x2 by negative point. If it is positive, then we replace by positive point. Okay, so let us discuss in the case 2. सपोज क्या वो पॉजिटिव वैल्यू डिफाइन होती है, ठीक है, नेगेटिव में क्या करना है, एक पॉइंट से रिप्लेस करना है, ठीक है, मींस a will be replaced by x1 in the next iteration. And in the case 2, suppose को पॉजिटिव वैल्यू डिराइव हो रही है, okay, f of x1 is positive, then your root will lies in between, means in next iterations root will lies in between a and x1. Okay, means we'll replace the positive point to the x1, okay, by the x1. Clear? Means your interval will be a to the x1, and the formula of x2 will be a plus x1 by 2. Okay, a plus x1 by 2. And again check f of x2. If it is a positive, then replace this x2 by positive point. If it is a negative, replace this x2 by negative point. Okay, so this is a procedure in a bisections method. Okay, what is the first step? Fx is given in the questions. Okay, you have to find out one interval a and b. Clear? Where f of a should be the negative, f of b should be the positive. Okay, then what does it mean? Okay, we can apply the IVT theorem. and we can say that there is exist at least one root between a and b, and it is our aim to find out this root. So how we can apply the bisections method? The first approximate solutions will be consider the average of a and b, a plus b by 2. Okay, and now check the function's output at x1. Okay, if it become a 0, then our process will stop that. Okay, means we'll say x1 is our answer. Okay, and if it is a non-zero, okay, so there is a two various cases, either it is positive or a negative. Okay, so if it is a negative, f of x1 is negative answer, then we'll modify our interval. Okay, so how we can modify our interval? Here x1 is a negative. Okay, so we'll replace this x1, okay, by the negative point. What is the negative point? A is the negative point where f of a is a negative. Okay, and b is the positive point there, because f of b is a positive. So if f of x1 is negative, then we'll modify our interval in the next iteration, okay, as a x1 to b. And for x2, we'll consider the average of x1 plus b by 2. Clear? And if it is a positive, then we'll modify our interval as a to x1, means we'll replace b by x1 because f of b is a positive. Clear? And then after check f of x2, if it is a negative, then we'll replace again this x2 by negative point, and if it is a positive, then again we'll replace by a positive point. So is it clear to everyone? Is there any doubt in this procedure? So if you have any questions, then you can ask me right now. Everyone understood this procedure of bisections method? Have you any questions, any doubt? Because it's very easy method. Just we consider the bisect of this interval. Okay, good. So there is no any doubt to anyone. And this is one graph is given here. In particular, suppose f of x1 is negative, then roots lies in between x1 to b, and then again bisect the interval to next point as x2 will be x1 plus b by 2. Okay, and repeat this procedure to generate x1, x2, x3, x4, and so on till the root up to the desired accuracy of 10. Okay, means which data is mentioned in the questions, which is a required answer, up to the 4 approximations, up to the 5 approximations. Okay, up to the 2 decimal place, up to the 4 correct up to 4 decimal place, and so on, which is given in the question. That up to this you have to repeat the this procedure, okay, to find the x1, x2, x3, and so on. And that is one graph is given here. What does it mean? Okay, here is functions that is mentioned here, graph by a red curve. Okay, that is fx is given here, and that is a b, okay, in the x line, x-axis, where f of b is a positive. So this is output is positive, that is positive y, and that is negative y. Okay, and at a, f of a is a negative. Okay, so this our curve of these equations, and at that point, okay, this is our required answer. Okay, but we directly we cannot predict that. Okay, okay, that will be the possible solution. We have to reach up to this point. Okay, so how we can reach up to this point? So by using the bisections formula, find first x1, means take average of a plus b by 2, check f of x1. If it is a negative, then replace a by x1. Okay, and if it is a positive, then replace a b by x1. Okay, and process up to the required answer. Clear? So is any doubt to anyone? Is there any query? Okay, so let's start the first question. Find the root of the equations x cubed minus x minus 11 equal to 0 using the bisections method up to the fourth approximations. What does it mean of fourth approximations? You have to derive the 4 iteration, means x1, x2, x3, and x4. Okay, x4 will be our required answer. Clear? Up to the fourth approximation means you have to derive the 4 various iteration, x1, x2, x3, and x4. Clear? So fx is given here, x cubed minus x minus 11, and as we can see that we cannot directly predict such x where fx become a 0. Okay, that is the power of x is 3 here, that is minus x minus 11, and this is our equations to find out its root, means for which value of x functions become 0. So in the first step, okay, that is one important note for all the student. Use the radian mode and in your calculator for solutions of any example of numerical method. So how many of you have calculator right now? Yes, how many students have the calculator? In the last lecture, I said about the calculator, okay, requirement of calculator, because each and every example need a calculator. Without calculator, you cannot write any step in the numerical analysis. Good. So when you start any example in a numerical analysis, numerical method, first consider the mode should be the radian. Okay, you can change the mode. There is one button. Okay, this calculator mode button. Okay, just press it and you can check that there is a three options, that degree, radian and gradient. Okay, so just mention the radian mode clear in your calculator, and if you have any doubt, then you can ask me how we can convert the radian mode in calculator. Okay, it's very easy now. I think you are familiar with the scientific calculator, and if you have any doubt, then you can ask me. Okay, so first consider the radian mode. Your calc should be in radian mode to evaluate the any example. Okay, in the numerical methods. This is an important note. And now find the interval AB. Okay, where f of a is negative and f of b is a positive. Find the interval AB where f of a is a negative and f of b is a positive. What is the equations? X cubed minus x minus 11 equal to 0. Okay, so here I consider the 2. Okay, you can also just 1 minute. Okay, we have equation is a x cubed minus x minus 11. Okay, so let us check for a 1. Okay, replace a 1. So 1 with the power 3. Okay, then after minus 1 minus 11. Okay, so that will be obviously negative answer. Okay, that will be 1 raised to 3 is again 1, minus 1 minus 11. So what is the output? That will be the minus 11. Now check for the 2. Okay, f of 2. So consider 2 with the power 3. Okay, then after minus 3, so minus 2 minus 11. So what is output of that? That will be the minus 5. So f of 2 is a minus 5. Okay, now check for a 3. Uh, 3 with the power uh, 3 minus 3 minus 11. Okay, so what is the output? That is a plus 13. Okay, so we here in this case interval will be 2 and 3, because at f of 2, okay, at the 2 f of 2 is a minus 5, and at the 3 f of 3 is a 13. Okay, so here get one interval 2 and 3 as a and b. Okay, f of 2 is a minus 5. You can check in your calc if you have any doubt. Then after consider f of 3, so it is a 3 cube minus 3 minus 11, so it is a plus 13. So it is a negative output, that is a positive output. So we can consider a is equal to 2 and b is equal to 3. So what does it mean? By using a IVT, okay, according to intermediate value theorem, we can say that roots of these equations will lies in between 2 and 3. Means our possible answer will be in between 2 and 3. Okay, it may be anyone, because there are infinite number in between 2 and 3. Okay, real number. So let us check the required answer up to the fourth approximations. Okay, so for the answer, you have to prepare this table. Okay, this type of table. The first column, okay, that will be the number of iterations. We'll mention the number of iterations here. In the second column, the values of a, where f of a is a negative. Okay, then after in the third column, we consider the b, where f of b is a positive. Okay, and then after our formula of bisection method, xn is equal to a plus b by 2. Okay, and then after the output of f of xn, it is a positive or a negative. Okay, so in first iterations, what is the a here? A is a 2. Okay, and what is the b? B is equal to 3. Okay, so find the first iteration x1. that will be the 2 plus 3 by 2. And what is the 2 plus 3 by 2? That will be the 5 by 2, and 5 by 2 will be 2.5. Okay, this is your first approximate answer. Okay, f of 2.5 will be the solutions. Okay, first approximate answer of the given equations. So now f of x, x1 is a 2.5. In the next step, you have to check the f of x1. Okay, means check the output of 2.5 of the functions. Okay, so it will be the 2.5 cube minus 2.5 and minus 11. Okay, and just check it in your calci. 2.5 cube minus 2.5 minus 11. Okay, 2.5 with the power 3, then after minus 2.5 and minus 11. Okay, so what is it output? I think consider one bracket here. 2.5 with the power 3. 2.5 the power, because there is a decimal value here, so I have to consider one bracket. Then after minus 2.5 and minus 11. Okay, so it will be the 2.125. Okay, 2.125. That is answer of f of 2.5, and it is a positive value. Okay, what is the answer here? This is a this is a 2.125. Okay, that is a positive answer. Okay, f of x1 is a positive. So what will be interval in the next iterations? Okay, so here at a 2.5 functions become positive output. Okay, so we'll replace this 2.5, okay, to the positive point. So what is our positive point? Of b, because at f of b, at a b, f of b is a positive here. So 3 will be replaced by a 2.5 in the next iteration. Okay, and here 2 will be as it is. Clear? And in the second iterations, we'll consider the average of 2 plus 2.5 by 2. Okay, 2 plus 2.5 divided by 2, and that will be the 2.25. Okay, that will be the 2.25. Clear? And again check f of 2.25. Okay, so that will be the 2.25 cube. Okay, minus 2.25 minus 11. Okay, so try it in your calci by yourself. Okay, what is the output of f of 2.25? So consider the bracket 2.25. Here it 2.25. Okay, 2.25 cube minus 2.25 minus 11. Yes, good. That will be the minus 1.8593. Correct. Okay, so it is a negative output. Good. That is the negative output of these equations of this data. That is equal to minus 1.8593. Okay, it is. Let's consider up to this. Now we can easily check that it is a negative value. Okay, that is a negative output. F of 2.25 is negative. So what we'll do in the second next iterations, okay, we'll replace this 2. Okay, because 2 is our negative output functions, negative output value. So we'll replace this 2 by 2.25. Okay, and here 2.5 will stay as it is. Clear? And then after in x3 we'll consider the average of 2.25 plus 2.5 divided by 2, and that will be 2.375. Okay, the average of 2.25 plus 2.5, that will be the 2.375. Okay, and now check f of 2.375. Okay, check the f of 2.375, and that will be 0. Just try it by yourself. I mentioned the direct value here, and just verify it this value. Okay, 0.2 0.0214843. Is it correct? Yes, 0.021. Okay, that's all. So it is a positive value. It's a positive output. So here this x3 will be replaced to the positive point. Which are positive point? This is a 2.5. Okay, So replace the 2.5 by 2.375. Okay, and here 2.25 as it is. And we have to solve the answer up to the fourth iterations. Okay, means in the fourth iterations, which value that we're getting here, that is our required answer. Okay, so just find out the x4 only. X4 will be 2.25 plus 2.375, okay, divided by 2, and that will be 2.3125. Okay, average of 2.25 plus 2.375 divided by 2, that will be the 2.3125. So this is our answer. Okay, this x1, x2, x3, x4 are the approximate answer of the given equations. Okay, when we replace 2.5 to the equations, we get output is 2.125. It is not nearer to the 0. Okay, then after at x2 at 2.25, we get answer is minus 1.8593. That is not also the nearer to the 0. But when we consider x3, that is a 2.375, the output of function is 0.021. So we can say that this value is nearer to the 0. It's not actually 0 there, but we can say this is a nearer to 0. Okay, and when we check the answer of f of 2.3125, that is get a nearer to the 0 answer. Okay, means this approximate answer there, and we can consider this a solution. Okay, this is solutions is our required solutions. Okay, and we can use it in such types of experiment where we need only the experiment when we need only the just approximate answer. Okay, so this is our solutions in these questions. Okay, in the questions that mention that you have to derive the answer up to the 4 iterations. Okay, means fourth iterations. You have to predict x1, x2, x3, x4. Clear? So this way you can derive the solutions. Okay, in the bisection method. First, you have to prepare find the interval a and b. Okay, where f of a is a negative, f of b is a positive, and then after you have to prepare such type of table. In the first column, the number of iterations. Second column, the values of the a, where f of a is a negative, values of the b, where f of b is a positive. Then after formula, xn is equal to a plus b by 2, and then after function output. Okay, and by using this, okay, it is also important for us. By using this, we can modify our interval. Okay, if it is a positive, then we'll replace this point by a positive to the positive value, and if it is negative, we'll replace this point to the negative value. Clear? So 2 and 3, that is our first interval, where f of 2 is a negative, f of 3 is a positive. Then find the first iterations, 2.5, and then after check f of 2.5, it is a 128. Okay, that is not 215, that is 128. Okay, 2.1, that is something values there. F of 2.5, that is a 2.5 cube minus 2.5 minus 11, that is a positive value. Okay, so replace this 2.5. Okay, ये 2.5 जो है, that will be replaced to the 3. Okay, why it is a 3? Because 3 at a 3, f of 3 is a positive. Okay, and then after check the second iterations. Okay, x2, that will be 2 plus 2.5 by 2. Okay, that is a 2.25. Again check the f of 2.25, and here we get a negative output. Okay, minus 1.8593. So now replace this 2.25 to the negative point. And what is our negative point? That is a 2. Okay, get 2, f of 2 become negative. So 2.25 will be replaced in here. Okay, in the this column, and here 2.5 as it is. Again take it average 2.375. Again check it output. Clear? So here we get a positive value 0.0214. It is positive. So replace this 2.375 to the positive point. Clear? And again take the average of 2.25, 2.375. That will be the x4, and x4 is a 2.3125. That is our required answer. Okay, that is our required approximate solution. Why it is up to the required? Because in question it is mentioned that you have to derive the solution up to the fourth approximations. Okay, what is our questions? Okay, predict the answer of this x cube minus x minus 11 up to the fourth approximation. Fourth approximation means 4 iteration, x1, x2, x3, and x4. Okay, so in x4 we get answer is 2.3125. Okay, 2.3125. That is our required answer. And now here there is no any need to verify f of x4. Okay, there is no any need to verify here f of x square, what the output f of x square. Clear? That doesn't matter here. This is our solution. Clear? So solution is the 2.3125. Okay, so now have you any query, any doubt? So you can ask me. And you can check that each and every step need a calculator. Okay. So without calculator, you cannot predict answer of any step. So everyone understood? Have you any query, any doubt? Okay, there is one question, sir, how we can find the values of A and B. Okay, that any value you can consider here. Okay, from the real line, you can start with the 0, 1, 2, 3, and so on. Okay, and then after replace this 0 to this function. Means what is output f of 0? That is a minus 11. Okay, that is a minus 11. And then after we'll find positive point. So when we consider f of 1, so f of 1 का answer भी क्या आएगा? That is also the minus 11. Clear? What is answer of f of 2? F of 2 will be minus 5, and that is also the negative. Clear? And when we consider f of 3, so f of 3 will be 13. Okay, 3 replace here in place of x, 3 cube minus 3 minus 11. So f of 3 will be plus 13. So it is a positive. So we can predict our range. Okay, means our interval will be a 2 and a 3. So Sivanand asked that do we have different final solutions if we choose? Yes, that are possible that. Okay, why it is possible? Because what is the power of equations? What is the degree of equations? X cube. Okay, means how many possible solutions of this equation? 3. Okay, so in such case, if we change this range, okay, means if we change this interval, we'll get another answer. Okay, it depends on this range, and you can verify that at a first point f of a means that point functions become should be the negative, and at the second point functions should be the positive. Clear? That you should verify first, and then after you can consider as the interval a and b. Clear? So if you change this range, okay, you will get another answer in place of that. That is also the right answer. That is not a wrong answer, because it is power is x cube. Okay, if it is x square, then we can find the two iterations, two solutions. If it is x cube, we'll get a three different type of solutions. But here, by using that, we can predict one possible solutions. This will be the approximate solutions of this equation. Okay, so now any query, another query, any doubt? Okay, good. In the example 2, okay, the function is different. In the questions 1, there is one polynomial there, and now it involves such trigonometry term. So perform the 5 iterations of the bisection method, okay, to obtain a root of the equations fx equal to cos x minus x e raised to x equal to 0. Okay, cos x minus x e raised to x equal to 0. Okay, so in the first step, first check the mode of the Kelsey should be in radian mode. If it is a polynomial, there is no any different, okay, in the answer if it is radian or degree. But when we consider any trigonometric output or any functions in the trigonometric term in the functions, you should just check that your Kelsey should be in radian mode. Okay, and then after you just check the output of A and B. Okay, so cos x minus x e raised to x is equal to 0. Okay, cos x minus x e raised to x equal to 0. So check the 1 and start with the 0. Okay, check the output of 0. F of 0. First consider cos, then after mention the 0. Okay, minus x, that is a 0 obviously, 0 into e raised to 0. Okay, that is a 0. So what is the output of cos 0? That is a e with the power 0. Okay, so what is it output? That is a 1. Okay, f of 0 you will get a 1. Clear? consider the radian mode first. Okay, there should be a radian mode, and then after you can check the output of 0. Cos 0 minus 0 into e raised to 0. Okay, in your scientific LC you just consider the uh, e, and then after write directly the 0. It will be directly predict that e with the power 0. Okay, आपको यहाँ पे जो डिफाइन किया है केप वो वहां पे मेंशन करने की जरूरत नहीं है. ठीक है, you just consider e and then directly write a 0 there. Okay, it will be predict e raised to 0 form. Okay, so cos at 0 f of 0 is 1, and now consider a 1. Okay, x equal to 1. So here it is cos 0 1 means cos 1, that is a 1 into e with the power 1. Clear? It is in such form, cos 1 minus 1 into e with the power 1, and identify output, that will be the minus 2.1780. Is it getting or not? Minus 2.1779. Yes. How many of you get this answer as a cos means f of 1 minus 2.1779? This our answer of f of 1. Good. Okay. So now interval is fixed. Our roots will lies in between. Here positive point is 0. Okay, positive point is 0 means b equal to 0, and negative point is a 1. Okay, that is minus 2.1780. It means a is equal to 1. Okay, so roots lies in between 1 and 0. Okay, remember one thing, we consider a negative point as a a. Okay, we'll use these notations for negative point, and positive point is a b. Okay, for f of b is a positive, f of a is negative. So here f of 0 is 1, it is a positive value, so b is equal to 0, and f of 1 is equal to minus 2.1780, that is negative, so a is equal to 1. Clear? So roots lies in between 1 and 0. So prepare one table, first column. Okay, here we require the 5 iterations. Number of iteration is a 5. Perform the 5 various iterations, 1 2 3 4 and 5. First column is the a, f of a is a negative, then after b, f of b is a positive. Okay, then after xn, a plus b by 2, and then check the f of xn. Clear? So in first iterations here, negative point, okay, that is 1, and positive point is 0. Clear? So here we'll replace a 1, a is equal to 1, and b is equal to 0. Clear? And then find x1, that is a 1 plus 0 by 2, and that is a 0.5. Okay, now check f of 0.5, means cos of 0.5 minus 0.5 into e with the power 0.5. Okay, in place of 1 just replace a 0.5. Okay, in this form, that is a 0.5 into 0.5 and with e with the power 0.5. Okay, this formations you have to type in your calci, cos of 0.5 minus 0.5 into e, and then directly write a 0.5. Okay, we do not mention there is a cap, because it's directly mapped this way. So what is it output? That will be the 0.0532. Is it correct or not? You get this answer, 0.0532. Good. 0.0532. Okay, this is here 0.0532. Okay, that is a positive solution, means it is positive answer, positive output. So we'll replace 0.5. Okay, we'll replace 0.5 to the positive point. Okay, so 0 will be replaced by a 0.5. Okay, and here 1 will stay as it is. Clear? In the second iteration. Now find x2, that will be the 1 plus 0.5 divided by 2. Okay, 1 plus 0.5 divided by 2, and that will be the 0.75. Okay, just take the average. 1 plus 1.5 by 2, that is 0.75, and check 0.75. Yes, what is the output of 0.75? Yes, just check it in a calculator and reply it in chat box. What is answer of f of 0.75? Yes, that is minus 0.85. Good. Okay, minus 0.85. Okay, that is a negative. Okay, that is less than 0. It's negative output. So we'll replace 0.75 to the negative point. Which is our negative point? Of 1. Okay, 1 is the negative point. So replace 1 by 0.75. Okay, remember one thing, ये जो आंसर हमें मिला है यहाँ पे रिप्लेस नहीं करना है. ठीक है, that is you have to replace this iteration x1 x2 x3 o replace होगा. ठीक है, in place of a and b. So 0.75 will replace, and here 0.5 as it is. Okay, and then check x3, that will be the 0.75 plus 0.5 divided by 2. Okay, and find out it average, that will be the 0.625. Okay, here it will be 0.625. Okay, and check f of 0.625, f of 0.625, and that will be, I think, again negative. Okay, just verify it, that will be the minus 0.3567. Just verify this. Okay, good. Okay, that is the correct one, minus 0.3567. Okay, that is also negative. So again, we'll replace 0.75 to the 0.625. Okay, and here 0.5 again as it is. And now in x4, that will be the 0.625 plus 0.5 divided by 2. Okay, and again bisect it in the x4, and that will be the 0.5625. Okay, 5625, that will be the average of this both. And again check f of 0.5625, and you will get answer is minus 0.1413. Okay, let's check it. F of 0.5615, 5625, minus 0.1413. Okay, that is also negative, and good, that is a negative. So in the fifth iterations, we'll replace 0.625 by 0.5625, and here 0.5 as it is. Okay, and now find the x4, x5, that is our required answer. That will be the 0.53125. Okay, average of this both, 5625 plus 0.5 by 2, that will be our answer. Okay, so this is a 5 iterations. Okay, and this is one approximate solutions of cos x minus x e raised to x equal to 0. Okay, there is just approximate solutions of this. Remember one thing, you will get a different answer in a radian degree mode. So just keep first calci in the radian mode, and then you can find out this type of value. Okay, so this is a table of this one, 1 0, and x1 is 0.5, f of x1 is 0.532, second iteration is 1, 0.5, x2 will be 0.75, and f of x2 is negative, so 0.75 will be replaced in place of 1, is 0.5 as it is. Again bisect it, check f of x3, it is also negative. Again replace x 0.75 by 625, and 0.5 as it is here. Then after find x4, f of x4 you have to check, it is also negative. So replace x4 by 0.625. Okay, and find out the final answer, that is 0.5312. So have you any doubt in this method? Is it clear to all? Have you any queries, so you can ask me, and otherwise we'll take the attendance and then we'll conclude our session. So any query, any doubt, so you can ask me right now. Okay, good. So let's take attendance and then we'll conclude our sessions. Just give me the 1 minute.